If you look at their structure, you can obviously determine that their leaving group, or what happens as you consider when you're thinking about the identity of Z, is a carboxylate anion, and that's a pretty powerful base, at least compared to acid chlorides. So there's kind of a bit more limitation in the amount of reactions that you can do with it. Obviously we can react these, and I'm just going to go ahead and keep it, I'm not going to color coordinate it because I feel like I've drawn it 100 times. We can react these with water to form a carboxylic acid. We can react these species with alcohols to form esters. Lastly, we can react these species with amines to form amides. Alright, awesome. In the last video, I didn't do an example of NH3 or NR3 nucleophile reacting to form structures, usually a secondary tertiary amide. So I figured I might as well go ahead and use anhydrides as an example of this, but just know that the leaving group is the only variable that's changed. I'm essentially in these videos going to be drawing the same 3 reactions over and over again. Not expecting these to get a lot of views, but good for review nonetheless. So we know that these reactions can happen with aldehydes or ketones, but we don't even need to have an acid or mildly acidic conditions. Anhydrides are so unstable that these reactions are going to proceed towards equilibrium on their own. So you have yourself a classic nucleophile attack, which moves electrons to the oxygen. Like before, you could either think of it as, and it doesn't really matter which step you draw next, you can draw the leaving group leaving, or you can draw a proton transfer reaction. I'm just going to stick with what my book says, and my book shows a proton transfer reactions. Now, one of the things that the book does show is using NH3 and 2 equivalents to deprotonate this to form an ammonia. I would rather use pyridine because that is a base that I can easily sacrifice. Pyridine is not going to be as reactive as a nucleophile, so I want to conserve as much nucleophile as I can, and I'm going to use pyridine. I'm not drawing it, but obviously this is going to be forming an ammonium ion that's going to obviously react with our leaving group. I think you know where this reaction is going. I would hope so at this point. We have a leaving group attached there. Oxygen doesn't like having that negative formal charge, and it goes ahead and leaves. Going ahead, and I just went ahead and drew the balanced equation of what I have here. I have myself a nice little amide that I've gone ahead and formed, and I have my ammonium salt here that's reacting in equilibrium. I'm sorry, my ammonium, reacting as a salt with the carboxylate anion.